every software vendor has encountered the discussion with a major automotive or aerospace company of no, we need that version supported for the next 10, no, 15 years. And that's a requirement from it. And this is the thing that I think the best articulation of it we ever saw was somewhere around 2006, 2007. Uh, Martin Mikos was still CEO at MySQL, and he was giving a talk probably at the Open Source Business Conference. And he made the observation that I think the toughest myth, the biggest lie we've told ourselves in the last 35, 40 years of open source discussions is that somehow.
Hello, my name is Ildiko,
And I'm Phil.
and this is the My Open Source Experience podcast.
Open source is freedom.
Open source is great collaboration.
Open source is good engineering.
Open source is not a business model.
Open source is community.
Open source is interesting.
Open source is the future.
Source is your opportunity to change the world around you.
Yeah, let's start recording. This sounds like fun.
Stephen, can you please tell us a little bit about yourself, your tech background, and what do you do now?
Okay, so I work at Microsoft. I work in the Azure office of the CTO in what's called the open source ecosystem team. So we're an outward-facing group of folks. We work with our partners, often through the nonprofits, where we're collaborating around those kind of supporting structures that support the open source projects that we care about, that we're building into, customer-facing product and infrastructure and such. I've been around this space for better part of 35 years, since long before we called it open source. And I think I was lucky that I got involved in the Unix standardization efforts back in the late 80s. And when you started going to conferences like Usenix, you were surrounded by this huge collection of folks, vendors, researchers from places like UC Berkeley, their computer science research group, or Bell Labs. And the idea that you'd be collaborating on a piece of software was just the way we got things done. Yeah, that point, X11 was on the rise. Well, X11 came out of an open source licensed collaboration between IBM, HP, and DEC. And it was like this period of history. We didn't call it open source yet. We in 1980, United States Congress slapped copyright law on software. So we were in this kind of exciting experimentation of using licenses to continue to collaborate in ways that we'd always collaborated. So the idea that you have researchers and companies collaborating on open source licensed projects together was normal. And I was really lucky that through that influence and through the standards work and the collaboration that happens with engineers in that kind of environment, I ended up in a startup mid 90s. And what we were building was the Unix interface on Windows NT, this kind of brand new Microsoft operating system. And we started with 4.4 BSD Lite because that was the distribution that AT&T's lawyers said the world could use. We were already into lawyers suing people around free, liberally licensed software. And so it was just this really interesting time. And so for 4 years, we were collecting together large projects of software. There was on the order, 250, 300 buckets of interesting technology covered by 25 to 30 licenses, some of which still aren't OSI approved, that we'd then, shape and assemble and evolve, because not all of them were standards conforming, into a standards conformant Unix interface that would build and run on Windows NT on 3 different architectures and provide you that kind of perfect fidelity of a Unix machine. So we weren't trying to emulate things. We had I guess that was the extra complication in this startup is we had a license for the Windows NT source from Microsoft, which was a fairly unique thing at that point in history. And so juggling all of these licenses, all of these collections of software, some of which, extremely proprietary, like the Microsoft license, like our company existed because of our protection of that license and the proprietary nature of it was normal to us and normal to run the complexity of the build trees across the multiple architectures. It was normal for us to contribute back to the projects with any major changes that we made. One of the biggest, changes we had to make, we needed control, just like every company, sooner or later, you need control of your compiler chain. And so we ended up in that space where every engineer understands build versus buy, and we couldn't pivot my startup team to build a compiler, and we certainly weren't going to buy 3 compilers for 3 architectures. So we used GCC because that was this fantastic base of code at the time. And I hired an HP compiler engineer with 20 years of experience in systems and compilers. And over the rest of that year, they built out GCC in our world. So I know exactly how to think about this idea that, okay, instead of build versus buy, we're doing this borrow and share thing with an open source licensed body of code. I know exactly how much his salary cost and what that meant for us in terms of the gain back. At the time, GCC was 750,000 lines of code. And we all hate lines of code measurements in our industry, but they're interesting relative measures. And so like that was just the experience from 95 to 99 of building this rich customer facing product out of all of these liberally licensed projects and contributing back where we needed to and knowing exactly what that engineering cost looked like as a company. And that, so I kind of carried that into, we did not make it as a company, but we were an asset acquisition back into Microsoft in 99. And so that was that period where Microsoft didn't really talk about Linux in those days. And open source was a very confusing thing. This is like 2 years after the first Halloween document, for those that remember the Halloween document. And so it's just been a really interesting 25 years since then. But that was everything that led into this. And so, I worked at Microsoft for 5 years in that period and got to see software delivery and deployment at extreme scales compared to most other companies. I've since then I've consulted, I've worked for an open source nonprofit. I had the pleasure and privilege of working at Hewlett Packard during the OpenStack period in Helion and got the exciting education of watching that shut down within HP. And continue. I ended up back at Microsoft again almost 7 years ago. So it's been a checkered career, but I've had a lot of fun around. Everything's always tied back to this idea of engineers collaborating, liberally licensed software, building products for customers. So that's kind of the big sway, kind of big sweep of my career over the last 35 years.
When it comes to you getting into open source, even before it was called open source, was that Unix standardization activity where you kind of learned about free software, the licenses, and all this collaborative efforts of working on software, like interconnected between companies, individuals, anyone interested in that kind of
Absolutely.
technology?
Like it was, if you went to a Usenix conference, and that was back in a period of history where there was an East Coast and a West Coast America Usenix conference every year. And that they were just starting to ramp up the system administration conference as well. This was this period of growth from, Unix being an interesting workstation to Unix being server workloads, and the early web and the rise of that period of the early internet. And it was Larry Wall talking about this thing called Perl that he'd invented as a language that made, and the fun of Perl was, you have to remember, creating processes on a machine was expensive back then, and some of the very complex things that people would do with, shell scripts, you know, the point of Perl was to be able to do it in a single process kind of thing and not have to spin up more processes than you had, slots in the process table. But that was the talk, Larry was standing there introducing the world to Perl at a Usenix conference. And, all of the research that was ongoing coming out of, around the BSD variants of Unix from the Berkeley CSRG, the folks from Bell Labs were standing there, introducing you to the toys that were their reality for this is version control. This is what make looks like. And some of all of these tools, they were all there as source code. We were into the early internet. If you lived in that Unix community, you probably had an email address. You probably knew how to telnet between machines. You knew what FTP was to move files around. Yeah, and as we came into the early 90s, kind of pre-web, there was, what was it? Ways, wide area information services kind of thing. There was just all of these ways of kind of passing information around and trickling it around an early internet. And it was normal. But if you go back prior to that, I mean, I spent the 80s working on DEC equipment. RSX was the operating system into VMS. And in that community, which was DEC crossed IBM's market caps somewhere in the 80s to become the largest computer manufacturer of the day. But there was something called the DEC Users Society, DECUS. You'd go to a DECUS meetup and the big conference once a year, for the outrageous sum of $75 for the cost of media and somebody's time, you would get a tape full of software. And some of it was binaries, some of it was source code that you had to build yourself. This was this early period, like some of it had, very strict copyright license on it because, we knew it had copyright. Some of it was like you had developers trying to place it in the public domain, which means something different in different localities around the world. But there was just this large sharing community where, of course, you spend your $75 to get a mag tape full of software. It's with the internet, our packet size just changed, and we weren't on mag tape sized packets and sneakernet at conferences anymore. But so that sharing thing has always been around. If you even go back earlier, IBM's conference was oddly enough called Share. That Share goes all the way back to the 50s. So we barely had computers and software, and IBM as the preeminent early manufacturer of equipment was already creating a conference environment where software developers were sharing software. So it's just been this long arc, and I was just lucky to kind of hook it at DECUS and then hook it properly in this new internet support. And a lot of creation of the early internet, again, the folks creating TCP/IP and such, yes, they were doing that in the IETF as a standards organization, but they were coming and talking about it at Usenix conferences. So again, there was that huge overlap in the 90s of just this early internet, the standards folks, the early implementations of the network, and all of the software that we could share on top of it. It was exciting times.
It's very interesting, like how much you're talking about the concept of sharing and working on things together existing for so long. And because like my personal career experience is that when you try to reintroduce the concept maybe at especially large corporations of this, we're working together with other companies, often competitors, on something that we all need and depend on. The idea just doesn't really fly that
I
well.
am going through that right now with a large group of industrial manufacturers. And culture is always important. We're talking about an industry with a very deep culture of building large industrial product, safety certification. So there's government regulatory action wrapped around this industry. If you're going to start building devices, that means we need a factory. In fact, building a factory, laying the bricks, pouring the concrete, that gets expensive very quickly. So, of course, everything is well specified, well architected, blueprints all over before you lay the first brick of the factory that'll eventually produce the thing. And so there's enormous capital expenditures up front and enormous regulatory pressure around. And now you step into this idea of software. And these folks have been using patents to protect their businesses for a very long time. And so there's a culture there, though, of, okay, so now we're going to collaborate. And we're going to collaborate as competitors in a culture of these huge capital expenditures all of the time, living in the world of bricks and mortar, living in the world of atoms instead of the digital world. And it's hard because they still bring that industrial manufacturing culture with them. And so there was a recent situation we were in. They described a couple of them. I've seen this from multiple of these high-end manufacturers now, describing this kind of software factory environment based on open source. And the hard thing is there's kind of this idea of, well, our suppliers who compete with one another will all go collaborate around the software that meets what we think are our requirements, but they'll be able to produce the safety certified product, software product that we'll buy as the primary manufacturers. And for our differentiation, well, we'll somehow make changes to these products because they're open source based and give that back to our suppliers to support. And I'm thinking, this is not a well-designed factory. Like none of the incentives exist, not technologically, not cooperatively and socially, not financially. There are no incentives that work in this factory. And when you approach it with, kind of their eyes and the way they've done things in their industry for, the past 100 years, it's like, well, we're collaborating on software. And instead, it's exactly that process of, I think the toughest myth, the biggest lie we've told ourselves in the last 35, 40 years of open source discussions is that somehow altruism has something to do with this. And it's not about the altruism in terms of we are all collaborating together for the greater good. It's actually more about generosity, where, let's say, Ildiko, you and I, we come up with this great idea for a piece of software. You're already the better engineer, so you're going to do most of the creation. But we're in that space that we choose to share that we've got working software, we've got just enough engineering activity and practice around it so that it's buildable in the couple of places that we care, and we are willing, we think we're going to share this. Not because we're being particularly altruistic and we want to necessarily build a large community, but just because there's nothing here. We're not going to build a company around this thing. It's useful to you and I. We're done, but we'll happily put an OSI approved license on it and park it on a forge somewhere. If somebody gives us an interesting contribution, great, but it's not like we're looking for them. And we've done that work, and that's now useful. A year from now, when, one of us has to go back, yeah, we can go back and pick it up from where we left off because we left it in a buildable state. Okay, we're doing open source. We have generously shared it outbound. There's a flow of IP outbound, but at no time have we invested in the rest of things. But we did it purely for selfish reasons, for ourselves. This is the old scratch and itch that everybody used to talk about. Okay, the second we say maybe we could build a community, we actually have extra work to do. And those community building activities of ensuring that we're kind of making it easy for users to try, because those users are going to lead to selfish developers. And I say selfish developers because that developer wants to do something for themselves. They either found a bug that we missed and they want to fix it, or they want to add some functionality, use it in a new way. But that still doesn't mean we're seeing anything back. We've just made it easy for that outward flow of intellectual property. And that last kind of on-ramp, users to selfish developers, is to turn them back into contributors. Allow that natural economics in engineering to kick in, that it's a whole lot easier for all of us to collectively manage the release if you give it back to us than for that person to continually live on a more brittle fork over history. And so but that's extra work. We've now had to put on a different new hat to build a community. And if we do all of that really well, we hit this natural wall of liability and risk where, if a company wants to sponsor you and I and our fledgling community doing everything right, but we're going to have a meetup and a company says, really love using your software. Can we give you a check to host the meetup? Who do they write the check to? Companies don't write checks to Steve or Ildiko kind of thing. Likewise, a company says, we really want to use this software. You seem to have liberally licensed it, but who owns it? Because we're about to use it in a customer-facing product, and they have a very different risk profile than you and I just solving a problem we cared about. And it's like, so companies care about ownership and provenance. And a simple nonprofit structure cleans all of that up. Nonprofit structure can own the asset. They can hold a bank account. You and I we have no personal liability risk anymore. There's kind of a place that the company can feel a little more confident that there's a center of gravity, not, Ildiko and Steve kind of thing. And, you know, but that's a separate set of skills again, right? Okay, now we're running our little nonprofit. But that's kind of the general flow of these things. And at no point am I suggesting that we are all in this together. Even in that community aspect, it's no, we've built a little factory of collaboration, if you will, where we've happily shared stuff out. We've done the work to make it easy for a user to get to a known state, a developer to get to a known state. We've told contributors, if you want to contribute for good reasons, here's how to do it. And that's the engine. And we're also like, we have a small sustainable engine at that point. We can allow Phil to join us. Phil's been making interesting contributions. We'd love Phil to join our fledgling community here. And, you can add another maintainer. And maybe Phil doesn't actually want scribble rights on the repos, but he's happy to actually manage the release every 4 months for the next year until he gets burned out and he wants somebody else to manage the release. And so we're into that space where, yes, we're all cooperating. We're all doing it for really selfish needs. This is, this has been the history around open source through those early years in the industry. It's the formation of the open source development labs. That was the world's big Linux OEMs. So all of them were hardware manufacturers. And Linus had just worked, he'd gone to work for Transmeta, and that freaked everybody out. Here's this primary architect of this Linux operating system. It's been growing for 7, 8 years, and he went to work for a vendor. Now, what does this mean for all of us that are starting to use this operating system? And so when Transmeta collapsed, the OEMs formed the OSDL, and the first thing it was to protect Linus's liability kind of thing and give him a job. And it allowed those OEMs to now layer in a message that was Linux IP is safe to use. Because you remember, like, Microsoft and Oracle in that period of history were, banging on about, amateurs in their mom's basement kind of thing. And this, you might get sued for using this stuff. So the large Linux OEMs had a reason to band together, to form a nonprofit to provide, kind of manage that, all the liability risk and all of the provenance risk that was going on at that period in history. We saw the same thing in Apache. The Apache web server, HTTPD, was this, growing thing that in this early web, 60, no, 65, no, 70% of the traffic was running through an Apache web server. And IBM wanted to use it in WebSphere. And so it was kind of like, who owns it? Well, it's a few dozen researchers and staffers at a collection of universities and a few other people. Okay, so that doesn't, if you're IBM with the kind of risk profile that you have for litigation, that doesn't give you confidence. And so IBM worked with partners to create the Apache Software Foundation to lift that nonprofit into place, to remove all of the liability from those developers, to provide a center of gravity for a provenance discussion. And if you even look at, I managed to pull the numbers. I don't know if you can still find them, but I have the graph that shows kind of in May of 99, there was about, I think it was 30,000 lines of code in Apache HTTPD. By September, it was 90,000 lines. Like, that was the pent-up demand of companies that really wanted to use this thing, but were really scared of using this thing. And as soon as you created that nonprofit shield and created that umbrella, all of a sudden, those companies could feel a little more confident in their use. They could make the contributions back. And when you think about it, like that became this really important leap-off point for the Apache web server. And so that's kind of the really simple model here. But at no time were any of those companies thinking, I really want to share our engineering resources. So to me, it's all about making sure you're actually looking at, we've got lots of good social structures that we've invented over, the last 5,000 years together to figure out how to cooperate around important things while we're all still kind of being selfish. And it's not that we are selfish human beings, like I'm selfish all the time kind of thing. I am about as far from a libertarian as you can get. But that idea that there is still, this company has a need to use that in a particular way. Their competitors or their partners have different needs and overlapping portfolios, but they can all satisfy those needs and share the cost of those very undifferentiated things. I think it's just, to me, it's a fascinating social experiment. The anthropologists should be looking at this.
So, Stephen, juxtapose what you just described with what you mentioned earlier with regard to large entrenched hardware type ecosystem vendors. Yep. Where they're confronted with not only the fact that this software supply chain is open source, but the speed with which the software evolves. There is no, There is no more waterfall. Let me build this thing soup to nuts in a design and walk
Absolutely.
through, and out the other end comes this product that I will maintain, but it won't add any features, right?
Right.
This thing will stay as it is other than for maintenance. So
Well,
that model is so different. So what do you see there from a
that's a really good question, Phil, because it's the timescales that matter. I mean, it's like every software vendor has encountered the discussion with a major automotive or aerospace company of, no, we need that version supported for the next 10, no, 15 years. And that's a requirement from an industry on a vendor that at least, I'm pretty sure SAP, Oracle, Microsoft are going to be around to support it. But it's the way I've tried to help folks think about this in companies is to be really crisp around the bright line that is upstream projects versus downstream product. And this is the thing that I think the best articulation of it we ever saw was somewhere around 2006, 2007. Uh, Martin Mikos was still CEO at MySQL, and he was giving a talk probably at the Open Source Business Conference. And he made the observation that, they have this huge community, and they also have lots of customers. And his community has time and no money. His customers have money and no time. And he knows which one he has to spend most of his time with as the business. But it was that recognition that within their corporate structure, they had a large community, engaged community of users and developers that they weren't going to buy anything. But downstream, you have products. Products have releases, products have, licenses and obligations on them and all the rest of it. So you can step into that space where the upstream project can be evolving very quickly. But as soon as you embed that software in a device, in an airplane or in a car, you now have a version that you can track. And it's that version. You might have all kinds of clever things. You look at the modern Tesla now and that the ability to be updating. So tree management is an engineering skill that these companies need to be really good at. But then we even saw that in the software world. There was a Slashdot Ask Me Anything with Jim Whitehurst a few years back, about 5 years ago now. As CEO of Red Hat before it fell into the maw of IBM. And it was a really interesting discussion because he was able to talk about how the next version of RHEL would happen. And yes, Fedora was involved as this upstream distribution project within the Red Hat world, but it also still evolved, pulling a particular kernel that they controlled the build of and layering, I think he said 2,000 patches onto it. Before that was the kernel that became the heart of the next release of RHEL, surrounded by the rest of the Fedora distribution. And it was a wonderful piece of software engineering. And at the time I was working for John Gossman inside of Microsoft, and the two of us were using this as kind of the stumping example as we walked across that this was equivalent to anything that the Windows engineering team was capable of doing over the previous 20 years. This is big tree management inside of a software culture. And so that's the kind of thing that, if you were working for an aerospace company or an automotive manufacturer, it's that recognition that software moves quickly, but there are these anchor points at release points, and you need to be good at tree management. And that might not be something they have historically been good at, but either they need to get good at it or they need their suppliers to get good at it, or kind of a combination of that.
Yep.
Because that's this crossover point. Upstream, we can be as dynamic as we need to be. In fact, that's the thing. I think there was kind of I had a laugh at one moment. There was a period early in my career where you could find the paper, the 1970s era paper that, 60% of the life cycle of software is maintenance. And, in the 80s, it was like, oh no, it's 70% of the life cycle of software is maintenance. By the time you get to the 90s, it's like, oh my God, 85% of the life cycle is maintenance. It's like there is no maintenance. That's the aha point. There is no maintenance in software. Software is this continuously evolving dynamic environment that we happen to take snapshots out of and call that, we used to call it software in a box. Now it's, the release today. And all of this tree management becomes so critical in terms of the software engineering practice to deliver and deploy software at scale. And that's I think the real growth in the industry. And that's the thing that got me involved in all of the kind of educational efforts that I've been involved in is a fear that that skill set is being diluted when all of the things have been democratized and anybody can be a net producer of software right now. We're drowning in the bad software of 200 million repos on GitHub. And it's like, okay, I'm pretty sure not all of that is really good software. And the ability to deploy software at scale when software is embedded in the fabric of all of the devices around us, that's a skill set that we need to get better at, not allow it to be diluted behind this wall of everybody publishing software. So, but it's a challenge. Like that idea of no, we build devices. I mean, can you imagine the shock? I'm not even sure how apocryphal the story is, but I've heard it enough times in rooms of automotive engineers. The Tesla, that people went from the idea of dog mode being, well, if I want to leave my dog in the car, why can't I just, turn on dog mode? And if the ambient temperature goes above a particular temperature, the air conditioning comes on. Why wouldn't you do that? And that went from idea to deployed on vehicles overnight in a few months. Now think about that from a traditional automotive hardware manufacturing cycle, where turning on the air conditioning is a set of buttons on your dashboard. Like, how do you think about that as a software change, a trivial software change, as an app that you would download to your car? And that whole pipeline, what does that mean when, the temperature sensor versus the button? Is dog mode a button on my dashboard? Like, how many model years do I have to wait for the dashboard design, physical design of the dashboard to change for there to be a dog mode setting on the, air conditioning panel? It's a different way of thinking about the problem with the speed that you can move at software. And so instead of specifying an architecture up front, you have to get comfortable with the idea of exploring the architecture in software, failing fast. Good engineers learn to fail quickly. And, that's always been kind of an engineering premise is, what'd you learn in the failure? The whole iron ring ceremony and the iron coming from the bridge that fell down. It's like, this is what engineers do, is deploy things at scale with a societal impact. It doesn't matter whether we're talking about an operating system on that plane or a bridge that spans a particularly busy span of water. That's what engineers do. And so you step into that space and it's okay. So a really interesting example right now out of the Eclipse software defined vehicle working group. General Motors is showing up as a member. They aren't a strategic member. The group that joined is actually an engineering team that's responsible for shipping vehicles. So this isn't somebody stepping in from, the lab organization or the CTO's office or something like that. There was basically an engineering team doing a project called U Protocol, which is a device communications software. And They built the software. It's shipping in vehicles. They've now open source licensed the project. They brought the project into Eclipse as an Eclipse project. And now they're working in the software-defined vehicle working group with their partners to ensure that the very tiny ecosystem around this project starts to grow. And, contrast that with the idea of how an automotive OEM might have done things historically 10 years ago. And it's that idea of they're aggressively exploring this idea of how do we evolve forward quickly around a software project with our partners, kind of bringing them along so that our partners are seeing revenue and a reason to be in the room with us while we're amortizing the costs and gaining the kind of new ideas to support this software that we believe is important. The fact that it's already shipped in a vehicle, that's that upstream project versus downstream product bright line. Like they know that there's a version of this software, regardless of what the upstream project looks like, that must be supported for the next 10 or 15 years, whatever the automotive industry does.
Right.
So it's a way of thinking about it that's just different. And it's getting comfortable with that difference if you want to take advantage of the benefits that come from that flexibility that software might give you.
Yeah. It's just such a cultural change though, right? I mean,
right. And there's no telling people, you're wrong, because they aren't. it's and you can be unfriendly about it. Well, those buggy whip, manufacturers, that were they ever surprised when cars came along? Well, yeah, but I'm sure that the economics was a little more complex than that. Changing cultures is hard. I mean, I'm even in shock coming back to Microsoft. When I left Microsoft, it was a company that was extraordinarily good in a couple of markets of putting software in a box. I came back to a company that's extraordinarily good at pouring concrete and running air conditioning. Like we deploy data centers with a global footprint. I have met and had the pleasure of working with the PhD. She and her team are our energy buying team. I had no idea we had one of those kind of thing, but they're working within LF Energy, trying to figure out what can be done in that space. And it's yeah, we have an energy buying team in Azure. And as soon as you say that out loud, it's like, well, of course we do.
Exactly.
And when you see your first data center that's kind of global footprint, and I have to assume all of the hyperscalers in all of the countries have these same challenges. It's, you're naive. You walk into it thinking of, yeah, I remember the data centers back in the 80s and 90s, but here it's like you have racks and racks and racks of different generations of hardware. And it's like you don't just throw out the old generation and retool the entire data centers. No, the infrastructure software is running across a physical hardware engineering problem that is the scale of some of this stuff is fascinating. And it's figuring out how do you run that hardware business underneath the software business, underneath the infrastructure management business. It's the complexity of the modern computing world is very different.
Yeah. And it is a reinvent for Microsoft, right? Like you said, I mean,
Yep.
they were very good at putting software in a box.
Yeah, and even when you see the difference in the way the three hyperscalers present themselves, I mean, Amazon, we all tease them, the bookstore is selling you, here's virtual machines as if they were books on a rack somewhere. Google's engineering based on how their investment in engineering practice and process early in their history 20 years ago was really interesting because as Bell Labs collapsed at the end of the 90s into the noughties, a lot of those folks ended up working for Google. And so you see that kind of careful engineering at scale kind of thinking that went into a lot of tooling investment kind of thing that everybody must use. And they built an advertising business on a very carefully thought through software architecture. And that kind of reflects out in the way they present their cloud. But it's very much we're the smartest guys in the room. You need to do it our way, and boy, will it ever work well for you. And Microsoft's kind of in there going, well, we understand how messy your data center is because we've been selling to you for a long time. And this is how messy our data center is, but we'll work together. And, we still have that kind of particular customer focus in that direction. And then Amazon just continues to do some really amazing things as software engineers in their environment. But again, it reflects their culture. All three of us, though, got really good at pouring concrete and running air conditioning. So and you have to see similar things in just what telco data centers look like at this point working for Ericsson.
Yep. Yep, they're much bigger.
Yeah.
Before we depart, Stephen, can you share something about yourself that has nothing to do with tech and nothing to do with open source? Some kind of a fun fact.
Okay. I like running. I like running and hiking. I like trail running, basically. And I don't do it as much as I used to, but I still love getting out there and just my wife is English, and we spend a lot of time in a small town in England where I am a short walk to that network of footpaths that covers England. So if I'm not sitting quietly in a comfortable chair like this one with a wall of books behind me, I like disappearing out onto a trail. I've got one right behind the house here, and like I said, the footpaths of England aren't far away either. So that's what I like doing.
Are you also doing like marathons and things like that, or just
Oh,
casually?
no, that's a young man's game.
Or maybe I know that there are some conferences where there are a group of people who are running together.
I have done those things. Yeah, so not for a while. The horrible thing about getting a little bit older is when you do something foolish and hurt yourself, it just takes longer to recover. So, yeah.
And with that, that's all, folks. That was our episode for today. We want to hear from you. Please leave comments under the episodes that you watched. Share your feedback and share your experiences to continue the conversation. And let us know what topics you would like to hear next. We already have a lot of great content lined up for season 2. We will talk about inner source, or in other words, why and how companies are using open source methodologies internally. We will talk about why and how governments are using open source and touch on upcoming legislations such as the Cyber Resiliency Act in Europe. We will also discuss how to create open source projects and communities that last for decades. Stay tuned because the next episode is just around the corner.
Wouldn't you wish there was a silver budget, but no, silver budget as well. Silver budget that is.
That's
a silver
what you
bullet.
need is a silver. Exactly.
That's it. And to be fair, some people.
So I bought some bidets. This should have been a very simple project. This should be simple. What bidet do you want? You install the bidet and you sit down and you enjoy the bidet. That's it, simple. But I bought the best bidet. And you know how engineers go. Nothing simple.
But we just had a good time just talking and whatnot. And by the end of it, he figured out I played pretty quick. So by the end of it, he actually made me play with him. And so I played music with Kix Brooks. That was fun.
Way cool. That's a great story.
He is waiting for me to finish this podcast so that I don't know if you